Hello developers, I am Veko and today we're gonna take on task 14 of the 2024 Advent of Code. Just a second, this is not the 14th of December when this task went online. Now it's 28th of December. After the 25th, all the tasks are available. Let's take a look at the calendar. I already have most of the stars, but I don't have all of them. So this is my after the fact solutions that I will try to solve whatever I don't have. So in this case, we do have some kind of map or something like that, and we have some robots that are going through it, and the robots are moving and moving and moving, and they are wrapping around. So when they get to this point, they continue on that side. So we have a Pac-Man scenario, basically an infinite set. So that's how it goes, and we just need to find out how many of the robots will be in which quadrant. This quadrant has 1, with this quadrant has 3, this quadrant has 4, this quadrant has 1 robot, and then we multiply everything together and we get a nice round total safety factor of 12. One thing that I kind of hate about this input is that we have two global hidden variables of the input, and that is the width and the height of this thing. So we're gonna start kind of with that. So as usual, I will define a global object, and I will say that the width is 11 and the height is not 11 but 7. Let's see if we can process the input. The input is given like this. Of course, if the format is something like this, we're gonna use a regex, and we're not gonna use our editor to write a regex. We're gonna use this thing, and I made this. So first we have a number, yet another number, a third number, a fourth number, and the third and the fourth number can be negative as well. So this is the regex that I'm gonna use to parse through the input. So we're gonna have lines.map, and each line will be just running through the regex const input regex is this. We're gonna match the regex. If we don't match, we're gonna just throw, because this is kinda invalid. No match found for that line. Otherwise, we're gonna have our values. We need to find the two position values. Those are x and y, and we're gonna parse in the match of 1 and 2. We know that there is a match, and we're gonna need to find the velocity, which is the third and the fourth thing, and I was supposed to enter this. You don't have to add the 10 for the last 10 years at least of JavaScript development, but I'm an old school kind of guy and I'm used to adding this, and it kind of looks incorrect to me otherwise. So what will our input actually be? Let's have an interface called point, and that has an x and a y, and an interface called robot. Yeah, it's a particle, but we're gonna call it like this. That has a position and velocity, which means that we're gonna return not an array of strings here, but we're gonna return an array of robots. That is our input. So we're gonna just return something that has this position and this velocity, and that is our set of robots. And of course, we need to close this and then return the robots, and everything is fine and compiling. Let's turn off part 2 for now because we don't need it. So let's start actually developing this. Let's console log our input to see that we actually managed to do it correctly. And as always, I usually say that I want to exactly replicate it, so let's see if we can do that. So console log, and we're gonna take our input and map it somewhere along these lines. We don't need to join it because console log can take care of that, but we're gonna want to have it in this format. So it's p equals the first one comma the second one, comma the second one, and then we have a space, and then we have the v equals first one comma the second one. Let's see if we are getting somewhere. No match found for line p equals this. Why not? Is that the first line? Yeah, it is. So we regex crept up even on line number 1. Why? I have no idea. It totally looks like it matches here at end of line. We have a G, we have an M. Because we are running input regex exec line, and I wanted to say line.match input regex. Let's see if this works. Nope. And it seems that everything would have worked except that I didn't check what actually compiler generated because we had a mental mismatch here. And I think that now I don't even need this. Yeah. Because we're said throw if it matches. No, it should be throw if it doesn't match. That looks quite okay. Now I will add the join on a new line, because that will provide me with a single string, and then I will do this copy and literally use the find function on my browser to see if we are able to find this. I'm guessing we're doing something wrong because it's not finding it in this way. 0,4, and if I paste it, it's exactly the same. Anyway, looks like we're reading our input correctly, so we don't even need this line. So what do we do? Now we're gonna need to move these things through our array. Let's see how that goes. So what do we need to do? Well, we're gonna run for each robot. Not that, but for each robot of the input, yeah. And we're gonna have we're gonna need to have the robot as a robot, or not really, position and velocity. So one way to do this will be to actually loop through the required number of positions, and that is 100 seconds. So we can do that if we want to. Yeah, let's do a very stupid brute force from 0 up to 100. Actually, let's call the current 0 and the last 100 because we have 101 steps if we do that. So we're gonna say position is that. We increase it by the velocity. But then also we will say if the position is less than 0 or it's bigger. Yeah, let's do it this way. If the position is less than 0, which means that we went in out of the grid on the left, we basically drove off of this side. That means that we can position.x. Yeah, we can do it like this, but we can just add the global width. If the position.x is bigger than the global width, we just remove the global width. And we can do the exact same thing, only, yeah, this is gonna be the other way around, if it's less than 0 or bigger and equal to the global width. And of course, Copilot generated it just the way that I wanted. That's it. At the very end, we have the positions. But note that we are constantly changing the positions, so we're gonna destroy our input, and I never want to do that. So I will define our robots to be the input, but mapped to. And now we have a bit of a problem, because we want to take the position and the velocity and kind of copying them over. So I will say, give me an object, because note that a robot is an object that has two objects inside of it. So if we just get those, copy over those, we will do a shallow copy. So those positions and velocity will be the same that the input has. We don't want to do that. So we will say the position is like this and the velocity is like this. So we're gonna kind of regenerate them. So this is a proper copy. So we're not gonna run through the input, we're gonna run through the robots. After this, we went through 100 iterations. Let's try to generate this, or should we maybe just go for the kill? Let's define 4 variables. First 0, that's the first quadrant. Second quadrant is 0. Third quadrant is 0, and a fourth quadrant is 0. I wouldn't do it like this if I had an unknown number of variables, so we're not going to have a fifth one or the second one. But in planar geometry, we will have up to 4 quadrants, because that's how numbers work. So now we can see if the position is literally less. Oh, it's something like this, but of course this needs to be variables, not constant variables. It's always fun that JavaScript has variables and constant variables. This is a variable. So if now the width and the height are both odd, so that means that for the 7 we have rows that are 0, 1, 2, 3, 4, 5, 6, 7 of them. These 3, which are less than half of 7 is 3.5. Ooh, half of 7 is 3.5, so it will use this as well. So we're gonna need to do which are less than half of 7 minus 1, half of 6, because half of 6 is exactly 3, and these 3 are less than 3, strictly less, and these 3 are bigger than 3, strictly less. So we're gonna need to rewrite that code once we did it. So let's get the half width, that's minus 1 and then divided by 2, and half height is minus 1 and then divided by 2. Note that since this will be odd even numbers, divided by 2 will actually provide a real number. It won't provide a fractional number, and that's always a problem in JavaScript. So this was half height. So something that x is less than half the height and y is less than half the, no, this is half width. Doesn't really matter actually which one is it, because we're gonna calculate them and we have 4 options, and we are using no. We're gonna need to use this because now we have a situation in position that y is equal to that, and we're gonna use strict equality here, and we need an if here as well, and we need an if here as well. This can be done in a much more elegant way using the modulo or something like that, or the coefficient actually, but let's leave it like this. And now we're just gonna console.log first, second, third, and fourth. And let's prepare for the result. Result is first time, second time, third time, fourth. Let's see if we actually did this correctly. It says 1341 and of course 1341, and the safety factor is 12. Let's try this with the bigger input. 500, and each of them we're pushing 100 items, so it's gonna be 500,000. So we got these numbers, and this is our proposed solution. Let's see if we got it correct. We actually might. We actually didn't. So we have a situation. Let's see what happens. Let's see now. Let's go. Oh, first of all, we solved the wrong problem because we forgot what? We forgot to change the globals, which is silly that I have to do all the time. So it's 101 tiles wide. So the width is 101 and it's 103 tiles tall, 103. Fortunately, there are just a few items when we have that. So we had these answers, and let's see if this is the correct one. Oh, it's loading. What are you loading? The moment of truth came, and once we actually solved the correct task, we got a gold star. 35 total so far. Let's see what part 2 is. I haven't done it. Hopefully, they're at the same time, they should have a hard-coded Easter egg. Most of the robots should arrange themselves into a picture of a Christmas tree. Wow, this is a really good task that we're gonna solve in part 2. So now we're gonna have to actually display them and see what happens. So we will actually need to, yeah, draw them like this and see if they are a Christmas tree. But I do have one idea that we can do. A Christmas tree will have the middle column totally full because it's like that. For example, we do have an example of Christmas tree for year 2015, and you can see that this line and this line are kind of full. Whatever happens, we have that this is a full. So we can use that as a checkpoint to see whether something is happening. For example, we can have, if most of the middle column is full, then display that on screen. But I think that for this task, we will have to use a Mark 1 eyeball to actually see what is happening. And we will need to change our code in a different way, because now we kind of evaluated each robot independently. First we took this thing, then we evaluated for that. We will have to basically re-evaluate all the robots in a given amount of time. So we will go one by one by one by one. Anyway, that's it for now. We got a star for the problem 14 part 1. If you like this content, click like, subscribe, and keep developing.